Zero dimension, dimensionless point. The zeroth dimension, or dimensionless point, might not make any sense. After all, how can there be a dimension that doesn't have any dimension? But the thing is that it's actually a straightforward concept. When driving to a specific location, you use your phone's GPS to know where this spot is. On the map, that point theoretically exists, but in reality, this dot doesn't exist and is only there to represent a location. In math and physics, these points represent positions or locations, and we don't even have to worry about how big or small these points are. They're placeholders that are simply there to represent precise locations in space. It's like having an imaginary friend. You know that this friend doesn't exist or take up space, but in your mind, it's like this friend exists in theory. Applied in your high school geometry, you usually used points to help describe the other dimensions, such as length, width, or height. They might not take up space, but they know how to show you the way. First dimension, length. Step outside your home and imagine a straight line through the sidewalk. Walk through this straight line without stepping sideways. You can only walk forward or backward. This journey represents the concept of the first dimension, which is length. Length is an important aspect of our world because it measures how far something can go in one direction. It only talks about movement along a straight line, like how something exists in an imaginary line from point A to point B. In between these points are objects or dots that exist infinitely. You encounter the first dimension every day. Something as simple as measuring the length of a pencil is already an application of the first dimension. Similarly, when you're drawing a line on paper, you're already using the first dimension's basic concept. Or even when your girlfriend talks about your performance in bed, she's already applying her basic understanding of the first dimension. Second dimension, width. Try standing up in place right now, and then step sideways to your left or right. You're already applying the concept of the second dimension, width. It focuses on how much space something takes up from left or right. There's a yo mama so fat joke somewhere here, but let's leave that up to your imagination. Width is essentially the horizontal measure of an object. When you look at a table, you think about how much space it takes up from side to side instead of how much space it occupies in a straight line in front of you. You encounter width throughout your everyday life. You're already using this concept when going through a doorway because you're subconsciously thinking about whether you'd fit through it. Essentially, the second dimension adds a layer of information about how wide something is, allowing you to understand how much space an object takes from a lateral or horizontal point of view. Third dimension, our dimension, depth. As you're looking at your phone now, you can pretty much measure the length and width of your screen, but there's another layer of space here, depending on your perception. We're talking about the distance between you and your phone from your point of view. In our world, depth is used to perceive how far apart things are. For example, depth tells you how far you are from the bookshelf if you're in a room. Essentially, it gives objects the appearance of being closer or farther away. Depth is also called our dimension because, in a sense, it's mostly all about perspective. It allows us to judge distances accurately without having to measure them. So when you're driving, you use your depth perception to tell how far your bumper is from the car in front of you and how much space there is between you and the vehicles around you. You're also using depth in something as simple as walking down the street because you can use depth to tell whether you're about to step on dog poop or a clean spot on the pavement. The third dimension is basically how much space we measure from our point of view instead of from another separate point. It's why our world has volume and why we can perceive distances. Fourth dimension, time. When watching a movie on your phone or computer, you can move the pictures frame by frame. You can rewind, fast forward, or pause the movie. This is how the concept of movement in the fourth dimension works. The difference, however, is that you're not watching the movie from the outside looking in. Instead, you're moving through time. This means that the fact that you exist is already the reason why you're moving through time. As you watch your screen, time is moving together because you're aging. The fact that you're aging allows you to move through it. Then there's Einstein's theory of relativity, which says time isn't fixed because it can stretch or shrink depending on gravity and velocity, among other factors. This means that people perceive time differently. When someone is moving faster or experiencing stronger gravity, time moves differently. However, unlike when watching a movie, it is still impossible to pause or move backward in time. Instead, we can only move forward through time unless we have a time-traveling DeLorean. The important part, however, is that this concept also allows us to understand that while we can't move backward in time, the past still shapes the future. Fifth dimension, Parallel universes. The fifth dimension concept, which refers to parallel dimensions, combines almost all of the things we know about the first four dimensions, but we add the element of choice in this discussion. The theory is that different realities exist parallel to the current reality that you live in. Your choices, as well as the choices of different people all over the world, help shape these realities. When faced with a scenario where you must make a choice, when faced with multiple choices, multiple realities immediately branch out. In this reality, you may be working as an accountant, but in reality number 355, you chose to become an astronaut instead. Because infinite decisions can be made throughout a day, the theory is that there are also an infinite number of parallel universes that all branch out from different choices. But there's a reason why they're called parallel universes. Take a piece of paper and draw two lines parallel to one another. No matter how long those lines are, they will never intersect. Likewise, parallel universes will never intersect, making these other realities impossible for us to access in theory. Sixth dimension, parallel universes plus time. You're probably already aware of how parallel universes work. These are alternate realities that exist alongside our own, but have a different set of events. But the element of time also adds a wrinkle to this discussion, allowing the theoretical sixth dimension to exist. In the sixth dimension, the concept of time connects the different parallel realities. These parallel universes still exist differently from one another, but time changes that concept, because you can now simultaneously see every possible parallel reality. Think of the sixth dimension as having a chart showing which actions lead to creating a new parallel timeline. It's a cosmic roadmap that may not necessarily connect every parallel universe, still it allows you to see how every action and event can shape the things that happen in one universe or another, as if they're all connected by these events. But don't think of it as knowing everything that can and will happen. Essentially, the sixth dimension only allows you to see every possible way the game could play out. It's like watching a walkthrough of a video game on YouTube before actually playing the game. Seventh dimension, alternate universes. Let's say that you live in a huge mansion with many rooms. Each room represents a different universe, and every universe in this mansion has different physical laws and possibilities. That is theoretically what the seventh dimension is about. Everything, every possibility, and every outcome is happening simultaneously, making reality seem like a giant library where every book tells a different version of reality. It's just that different things are happening in all of these universes, and they may have different rules of physics. It's not the same as parallel realities, where every reality is similar to the reality that we know of, but has different events. Instead, these universes are entirely different, and any outcome is possible. Think of the seventh dimension as a place where all possibilities of existence can happen and are laid out in front of you in different universes. As difficult as it may be to imagine what the seventh dimension would look like, don't forget that this is completely theoretical. Eighth dimension, alternate universes plus time. When we talk about the seventh dimension, we're looking at a tree of possibilities, where every timeline and universe is right in front of you, happening simultaneously, but in different universes with their own set of rules, events, and realities. But in the eighth dimension, we go beyond just these different universes branching out. Instead, the eighth dimension talks about how these timelines could interact with each other, creating a complex web of possibilities. Simply put, the eighth dimension goes beyond all of the possible timelines and how they interact with one another in a vast cosmic playground. Think of it as a dance floor, each dancer representing an alternate universe, but whenever these dancers interact with one another, they create new possibilities. In this dimension, the concept of cause and effect goes to an entirely different level, making everything that happens, has happened, and will happen intertwined with each other. This allows the past, present, and future to affect each other across every universe. It can be a headache to imagine what this stuff is all about, but if physicists go crazy trying to make sense of this concept, let's just say that it's perfectly fine if you don't get what the eighth dimension is. Ninth dimension, above reality concepts. Let's look at what we know about the physical realms of physics. We know that the first three dimensions are all physical. We're talking about length, width, and depth, which allow us to understand how objects take up space. Then the fourth dimension of time allows us to understand motion and change. But as we move beyond the simpler dimensions, things get more complicated. The ninth dimension exists as a way out of the realms of reality. Let's look at the dimensions as a box that limits the laws of physics, such as space and time. But in the ninth dimension, the box doesn't exist, because everything we know about the other dimensions gets thrown out, and it's entirely possible that physical laws don't apply here. Think of it this way. The first three dimensions allow you to feel an experience similar to watching a movie on a screen. On the other hand, the ninth dimension allows you to step outside the movie. You are no longer the things happening in the movie, making it an entirely different experience. Some theories suggest that all possibilities and timelines can exist in the ninth dimension at the same time, making it some sort of a super multiverse. It suggests that every choice you make and every event that could happen already exist in this large tapestry of possibilities that don't even care about the traditional laws of physics or the first four dimensions. Then again, the ninth dimension and all the other higher dimensions are entirely theoretical, existing only in the minds of the most imaginative physicists. 10th dimension, higher dimensions. In the 10th dimension, we're not just looking at different timelines and alternate realities. Instead, we're looking at higher dimensions that allow reality to unfold from the smallest particle to the largest cosmic body in the vast multiverse. It's like you have a table of possibilities where every scenario and variation of existence is laid out like cards. But what makes the 10th dimension unique is that you're not just looking at different versions of reality happening right in front of you. Instead, you're theoretically looking at the very fabric of existence itself. To put it bluntly, it's not another layer of reality. The 10th dimension is essentially a backstage pass to how the universe unfolds and what kind of grand design has led to the creation of this giant cosmic multiverse. From the birth of the stars to the death of the tiniest subatomic particle, you see it all in a dimension that blurs the boundaries between what is happening and what could happen. It's difficult to understand, but this concept allows you to see just how complex the true workings of the universe can be. 11th dimension. Theoretical omnipresence. You're walking on a steep ledge on a cliff. You can walk forward, backward, and maybe even sideways. Those are the first three dimensions. Now, the vibrations from falling rocks on the cliff add a new dynamic to what you're doing. The vibrations represent the fourth dimension, time. Now, let's say there are more ledges. They all vibrate differently. Every ledge represents a different timeline or possibility. This represents the fifth dimension, which discusses parallel realities that branch off from other realities. But when we get to the 11th dimension, which is rooted in string theory, there are additional spatial dimensions well beyond the three dimensions of space that exist in reality. The 11th dimension is theoretically a spatial dimension that serves as the master dimension where all of the different variations of string theory can coexist, making it a meeting place for all those complex cosmic ideas. There's also the idea that the usual particles and forces we observe in our three-dimensional world may originate from more complex interactions in the 11th dimension. That's why the theory is that concepts like gravity, dark matter, and electromagnetism can be understood at a more fundamental level in higher dimensional realms, such as the 11th dimension. When applied in metaphysics, the 11th dimension could be a form of omnipresence, because everything exists at the same time across this higher spatial dimension. While it's impossible to hop on a plane to go on a trip to the theoretical 11th dimension, knowing that this realm possibly exists could change how we view our reality. Liar paradox. Your friend tells you that he's always lying. At first, you didn't think much of it, but then you realize that if he's always lying, the statement he told you was also a lie. If he's lying about always lying, that means he was telling the truth that he was a liar. But if he was telling the truth, it now contradicts his original statement that he's always a liar. It's like a snake eating its tail, or a cat chasing its reflection. That's basically what the liar paradox is all about. This paradox lets you step into a mere funhouse of logic, where your argument always gets reflected to you. It's as if your mind is playing a non-stop game of ping pong where the ball always bounces back at you no matter how hard you hit it. The liar paradox creates a logical loop. Suppose the statement, "This statement is false," is true. Then that must mean it is false. But if it's false, then it's true. This is where the loop happens, as it never stops being a question of whether it's true or false. You're now basically in an endless debate with yourself. Ship of Theseus. Let's say you have a ship sailing the rugged seas for a while already. It's been through some tough times, dodging cannonballs, wrestling with a few krakens, and surviving a few storms. It eventually becomes more like a shipwreck than a seaworthy vessel, so you start swapping every old part with a new one to make it as good as new again. Over time, the ship gets damaged again and needs more replacements. That's when all of its original parts have been replaced with new ones. Now the question is whether or not this ship ship is still the same old one. But here's the bigger question. If you took all the old parts from the ship and rebuilt a new ship, which of the two is your ship? You see, the paradox of the Ship of Theseus tackles fundamental questions about identity and change. It looks at whether something retains its identity after undergoing a series of changes that have altered its appearance. For example, if you got all sorts of different plastic surgeries, such as a Brazilian butt lift or some implants in your melons, does that mean that you're no longer the same person you were before because you're now a thicker version of your old self? The argument is that it all boils down to the object's function. So if the ship continues functioning like the old ship, it's still the same. But others believe it's more of a question of identity, meaning as long as this new object still identifies itself as the old object, its identity never changes. So whether you're the Ship of Theseus or the Ship of Thickeus, it's all about how you identify yourself. Grandfather paradox. The grandfather paradox is a big oops in the philosophical and hypothetical topic of time travel because it creates a possible moment when you cease to exist. So let's say you invented a time machine and traveled back to meet your grandparents when they were single. But you thought that your grandfather was a big jerk when he was 25 and decided that grandma was too good for him. You prevent them from meeting. If that's the case, your dad shouldn't exist. And if he never existed, you also don't exist. But the real paradox happens when you think about this. If you don't exist, you wouldn't have been able to stop your grandparents from meeting, so no one would have been able to mess up their love story in the first place. You should still exist if no one stopped them from doing the deed in bed, and if you existed, you would have gone back in time to stop them from meeting. It creates a logical loop where every argument and question makes sense. However, this is where the more boring physics topic comes in, explaining that every decision creates a different timeline of events. So if you prevented your grandparents from meeting, that doesn't change the future events of your timeline, but only creates another timeline. But unless you find a way to invent a time-traveling car, there's no way for you to tell if you can trim your family tree back into a shrub. Sorites paradox. You're on the beach one day and a wave of boredom hits you. You decided to gather some sand and started counting every grain. You found that there were precisely 10,000 grains in that heap. Then you got bored again and took one grain away. It's still a heap because having 9,999 grains doesn't change it much, but when you start taking more grains, the term heap now becomes vague because you don't know when the heap stops becoming a heap. That's the Sorites paradox in a sandbox. This paradox explores how small and seemingly insignificant changes can eventually lead to something bigger. Let's say that you're organizing your socks. You start with a bunch of blue socks and begin swapping every blue sock out with a green sock. One green sock doesn't change the entire bunch, but when you keep swapping, you look at a pile of primarily green socks. But the question is, when did it switch from being mostly blue to primarily green? Applied in your growth, the Sorites paradox makes you wonder when you become an adult. You just don't grow from being a 10-pound baby into a 200-pound adult as soon as you hit 20 years old. Instead, you undergo minor changes that incrementally turn you into an adult. But the paradox wonders when a baby turns into a grown-up. Did you turn into an adult when you got circumcised? Or did it happen when you drank your first beer? No one can answer that question. Barber paradox. Let's say that there's this famous barber in town. Call him Bob the Barber. He's got a reputation as sharper than his scissors, and everyone wants him to be the only one cutting their hair. But he has one rule: only shave those who don't shave themselves. If you shave yourself, Bob won't ever offer his services to you. One morning, Bob realizes that his hair and beard have become too long that he could give Bigfoot a run for his money. That's when he wondered if he should shave himself. But if he did, he would violate his rule of shaving only those who don't shave themselves. On the flip side, if Bob doesn't shave himself, he falls under the category of people who need to be shaved by Bob. So it becomes a classic case of to shave or not to shave. He's now in a hairy predicament. The barber paradox creates a situation where following the rules forces you to break the rules. But if you don't follow the rule, you also break the rule. This problem leads to a contradictory loop that becomes hard to solve using traditional logical rules. Bootstrap paradox. One day, you created a time machine. You decided to go back to 1980 to meet Michael Jordan when he was in college. As a token of your appreciation for his legendary status, you gave him a pair of one of his Jordan sneakers. The problem is that the first Jordan shoe was released in 1985, well after you gave MJ your gift. But Jordan got inspired by the shoes you gave him, so he decided to team up with Nike and release more similar shoes. So as you return to the future, the same Jordan sneakers you brought back in time are still there in your home. What you've just pulled off is the bootstrap paradox. You thought the Jordan sneakers existed because Michael Jordan released them in the 1980s, but on Jordan's end, the sneakers came from you. Now it creates a paradox where no one knows where the sneakers originally came from, keeping you trapped in a loop tighter than any shoelace. In simple terms, this paradox exists when an object has no clear origin. Draw a circle on a piece of paper and ask people where the starting point and the circle ends. No one could tell you the answer because the circle itself has no clear starting point or origin as far as others are concerned. It's the same scenario in the bootstrap paradox, where you'll be left wondering which between the egg and the chicken came first. Banach-Tarski paradox. Take a solid ball and split it into finite pieces. Now this is where it gets wild. According to the Banach-Tarski paradox, you can take all these different pieces and reassemble them into not one, but two balls. You're not looking at two balls smaller than the original, but two balls identical to the last. It's as if the original ball came back from the cloning lab and came back with a twin brother. But there's no special magical trick here. This paradox relies on some very deep ideas from set theory and geometry. It involves points in space and the concept that they can be rearranged. By relying on that concept, you can create an infinite number of different objects from one object. So if this worked in real life on an entire pizza, then you'd be having two pizzas for the price of one. But the sad part is that you can't do this trick for an infinite food hack that would turn you into a viral Instagram sensation. This is only theoretical because creating something out of nothing is physically impossible. Still, the paradox challenges what we know about space and volume. It's like you went on a trip to IKEA and discovered that you can rearrange your room and fit two beds in the same space that could only fit one bed before. Paradox of the unexpected hanging. Let's say that you're a criminal about to get hanged for your misdeeds. Your executioner is a bit mischievous and tells you that you'll be hanged on a surprise day of the week, but you won't know when until the last minute. But you tell the executioner that you can't be hanged on a weekday because if you haven't been hanged by Thursday night, Friday would be too predictable, making the surprise execution not so surprising anymore. You thought you had found a way around the system, and then you started using the same reason each day of the week, eliminating them all until you concluded you wouldn't be hanged since it would contradict the surprise condition. You're now safe from the gallows. Or so you thought. The executioner tells you that you're going to get hanged on Wednesday. You're shocked because, according to your logic, Wednesday and every other day should have been ruled out. It looks like your logic took a noose dive because the executioner found a loophole in your calendar of excuses. The paradox in this situation talks about the contradictions between logical deduction and surprise. You thought that you had it figured out and outsmarted fate, but a surprise doesn't play by the rules in a tug of war against logic. After all, if you could predict a surprise, you wouldn't call it a surprise anymore. There is a conflict between the two ideas here because your logic is trying to make sense of something that shouldn't make sense. Intrigued by paradoxes and the interplay between logic and surprise? Join our Discord community, where we unravel such mind-bending mysteries together. Omnipotence paradox. You've got this cosmic hotshot claiming he can do anything, like a true god. He creates the galaxy and everything in it. But if this being is so great that he can create anything, you'd be wondering if he can create something so extreme that not even he, with all his omnipotent powers, can handle it. A rock that's so heavy that no one can lift it. If this being could create a rock that not even his divine muscles could lift, that would mean he's not all-powerful. After all, a perfectly powerful being should be able to lift anything. But if he can't create a rock that's impossible to lift, that would mean he can't create anything, defeating the meaning of omnipotent. It's now a rocky situation for this being, and he's stuck between a rock and a hard place. The paradox goes back to the question of whether or not God exists as a truly omnipotent being. After all, if he's the top dog in the universe, he should be able to create something that not even he can destroy. But that defeats the purpose of having limitless power. Twin paradox. Let's look at two twins. One is Anna, a homebody who just loves staying at home to binge all the Netflix shows. Meanwhile, Eve is an adventurous astronaut trained to travel the cosmos. One day, Eve hops into her spaceship and flies at near light speed to boldly go where no man has before. Meanwhile, Anna stays home, munching on popcorn while flipping between movies. However, according to Einstein's theory of relativity, the faster a person travels through space, the slower time ticks for her. Traveling through space at near light speed gives Eve a slow motion button for life. That means her aging will be several times slower than her twin sister, who's back on Earth and aging normally. So by the time Eve returns to Earth as a hero, it's as if she hasn't aged a day. On the other hand, Anna has aged faster than moldy cheese inside a refrigerator. She now has gray hair and is wrinkled, after beating the world record for most TV shows binge-watched in a lifetime. This paradox means that even though Anna and Eve were born simultaneously, a paradox can arise because our ordinary understanding is that time ticks away uniformly for everyone. Relativity, however, changes this concept, especially when dealing with extreme speeds and gravitational forces. This effect has been tested and confirmed through experiments with atomic clocks and high-speed particles, proving that time can slow down for particles moving at incredible speeds. Paradox of tolerance. Let's say that you live in a super chill society where everyone's all about accepting different views and ideas. People say, yeah, I respect that you like pineapples on pizza. Now everyone would want to live in a place like that, but the problem here is that everyone is so open-minded that you might end up accepting ideas that aren't quite open-minded. It's like you're all hosting a potluck dinner where all dishes are welcome, but one of the guests brought in sardines dipped in marshmallow cream. Usually, in a perfectly tolerant society, you'd allow that guy to bring his unappealing food and eat it, but the dish is so disgusting that it shouldn't even exist. The paradox of tolerance warns that if a society is overly tolerant by allowing all ideas without limit, it risks being overtaken by people who exploit that tolerance. Simply put, if you're too chill about everything, you might find yourself in a chilling situation where people abuse your tolerance for everything. The paradox of tolerance also teaches that there should be a sweet spot between tolerance and intolerance, and finding the spot where we draw the line is one of society's challenges. Many worlds interpretation. When you're at a crossroads, you only have two choices, either the left or the right. You can't take both roads unless you can split your body in two, but the Many Worlds Interpretation, or MWI, says that you can take both the left and the right paths simultaneously. The idea is that every time you make a decision at the quantum level, which is the smallest level in the physical world, the universe splits into multiple versions of itself. Each version represents a different result based on the decision you made. So if you wake up today and choose between taking the day off or going to work, the universe splits into two versions, one where you go to work and the other where you stay at home. The MWI suggests that all these states are real and that each of these states exist in their own universes. Basically, the MWI removes the idea that there is only one outcome for every decision. Instead, it says there are infinite parallel universes where every outcome can happen. There's one universe where you became a lawyer, while another universe has a version of you that's a doctor. These universes are all based on the individual decisions you make daily, and that's why there's an infinite number of them. Cosmic Inflation Multiverse. Meet Cosmic Inflation. He's the Big Bang's weird cousin. According to Cosmic Inflation's story, the universe kept expanding at a rate much faster than the speed of light after the Big Bang. It's essentially the reason why our universe is so big that it's almost impossible to know whether there's an end to it. But the twist is that during Cosmic Inflation, some parts of the universe may have expanded at different rates, leading to the possible formation of pockets. These pockets could potentially become their own universes, each with different characteristics. Put it like this, when you're kneading a large piece of dough, you can take another smaller piece from it. This small piece can be its own universe because it already has a different identity from the larger dough. It's essentially a pocket universe. Put all that together and you get the multiverse. The idea here is that these universes exist in our universe, but in pocket dimensions, or realities, that may have their own set of laws. It could be possible that one dimension doesn't have gravity at all, while another one doesn't support any kind of life. The stars you gaze at during a clear night may be pocket dimensions far from our world. The next time you go stargazing, you're probably staring at another version of you staring back from a different universe. Bubble universes. Let's say that the universe is a huge soap bubble. The bubble contains everything we know exists, including galaxies, stars, and planets. This bubble now exists with hundreds of other bubbles. Pardon me. This bubble now exists with hundreds of other bubbles in a cosmic bathtub. So if there are other bubbles, that means that each bubble has its own universe inside. This is the idea behind the bubble universe theory. The theory is rooted in what we call cosmic inflation. After the Big Bang, the universe expanded so quickly that it's like you're inflating a balloon. Scientists believe this inflation also inflated other universes to create a larger multiverse. Each bubble could be different from the one we know. For all we know, one could be a 2D cartoon universe with different physical laws. Others may be similar to our own universe, but with slight differences. The idea is that the possibilities are endless, and each bubble represents a different possibility. Scientists use the bubble universes theory to explain our universe's properties. If there are many different universes with properties different from ours, we live in a universe with the perfect conditions for survival. Anthropic principle multiverse. If you go to a library to browse through books, you'll see that each book tells a different story, but not every single one keeps your interest. But there's that one book that keeps you engaged, almost as if this book was perfect for you. You'd probably think, this book gets me. Hey, maybe it was written for me. Now consider the anthropic principle multiverse theory. It suggests our universe is just one big library in the larger cosmos. Each book in that library represents a universe with different stories and rules. According to this theory, we exist in the universe we live in now because it has perfect conditions for us. For example, if we removed Harry Potter from his book and transferred him to Tuesdays with Morrie, it's clear that he doesn't fit in that book. But he exists in his book precisely because that book was written to fit him perfectly. It's just like how our universe is perfect for our existence. If we were taken out of our universe and placed in a different one, there's a good chance that the conditions in that universe wouldn't fit the requirements for our existence. This theory supports the idea that parallel universes exist, but have conditions different from the conditions of our universe. So if you ever feel lost in this vast multiverse, remember that even parallel universes have a "you are here" map, and the here we're talking about is the universe you live in, because that's the only one that supports your existence. Membrane theory, brain multiverse. Look at the universe as a trampoline, or a giant sheet called a brain. Every jump or movement on this trampoline affects it, which explains why the sheet moves as we bounce. This theory, known as membrane theory, suggests that our universe is just one of these brains existing in a larger realm called the bulk. Think of the bulk as a giant trampoline park with different trampolines. Each trampoline has its own unique set of laws and realities, just like different trampolines can vary in size and bounciness. For example, the trampoline next to you might look the same, but it's actually a bit bigger and allows you to bounce higher. This trampoline next to you is what you'd call a parallel universe. That's how these brains in the membrane theory work. According to this theory, these brains can even interact with each other, similar to how you can jump from one trampoline to another. But if two brains collide and interact, it could have an impact. Scientists think that a similar collision could have caused the Big Bang. Two different universes in the bulk likely collided and created the universe we live in. This is like how two people jumping on different trampolines can collide if they jump close to each other, but instead of another Big Bang, they get a big ouch. Simulated reality. You're probably familiar with video games where you're the main character. There are other characters in this large virtual world. It's like an MMORPG where you can go on quests with different players but still create your own story. This is what simulated reality theory talks about. The basic concept of this theory is that advanced beings are running our lives. They create simulated video game-like worlds. These simulations are our universes. We are just simulated beings in these virtual worlds. Essentially, we're ones and zeros in a binary digital world created by aliens, gods, or these advanced simulations. But we're not the only simulation we are running. Other simulations are running alongside our own. The parallel universes also exist in their own simulated worlds. Think of it like you're hosting a huge gaming party with your friends, but every single one of you plays different games. These games represent the different universes in a large computer room. At the end of the day, nothing in our universe is real, because everything was just digitally created, and all other universes in this vast room full of simulations are also made-up dimensions. Quantum decoherence. Let's say that you have a cat named Felix. Normally, Felix can be either awake or asleep, but in the quantum world, the concept of superposition allows Felix to be awake and asleep simultaneously until you observe him. Quantum decoherence comes in this scenario to make you understand why Felix chooses to be either asleep or awake. It's as if something happens that makes him choose either reality instead of both. When applied to the quantum world, quantum decoherence talks about how particles, like electrons, are no longer in a state of superposition. Instead of being asleep or awake, these particles are forced to decide on a definite state because of how their environment interacts. Once a particle chooses its state, the universe splits into multiple versions, each representing the different states that the particles chose. This creates multiple universes and answers the mystery of why we can't see or interact with other universes. When a particle chooses its state, there's no coming back. You can't rewind things and decide to follow a different path. So if Felix woke up because a dog was barking, you can't go back to the past and look at the universe where he stayed asleep. Similarly, if you chose losing lottery numbers, you can't reset things and observe the universe where you choose the right numbers and won $10 million. That's how quantum decoherence applies to our understanding of the multiverse. There's no undo button in it. If you're also in a state of superposition, you can fix that by joining our Discord. But once you do, there's no coming back in time to look at the universe where you didn't join our Discord. Well, that universe sucks anyway. Holographic principle. You probably remember the hologram stickers you got for free in a cereal box when you were a kid. These stickers project 3D images, but in reality, it's just a two-dimensional surface designed to look like it's three-dimensional. Scientists apply the same logic to the holographic principle when understanding the existence of multiple universes. This theory suggests that all the information in our 3D universe can be represented on a 2D surface, which could be the universe's boundary. So if you're looking at our universe from the outside, it's like viewing it on a piece of flat 2D paper. Let's use soup to give you a better understanding of this concept. When we're eating a bowl of soup, you know that everything in this soup is spread throughout the entire bowl, but if we apply the holographic principle to this discussion, you don't need to dig through the entire soup to know what's inside it. You can just look at the bowl's surface to see pieces of chicken and carrots floating. You're just viewing the contents of the soup from a flat 2D surface. Because of this, scientists believe our universe is merely projected on a flat 2D surface, even though it's a three-dimensional reality. If that's the case, then there could be other universes that are being projected on this flat 2D surface to create a multiverse. We are essentially just hologram stickers pasted all over a wall by a cosmic version of a child. Temporal parallel universes. Maybe you've read one of those choose-your-own-adventure books before. These books allow you to make choices that send you down a new path. Every path is different, depending on the choices you make. Every time you reach a decision point, you're not just picking a page to turn to, instead you're splitting the universe in two. It's like, should I slay the dragon, or try to reason with it? Oh wait, let me just create a whole new parallel universe where I'm a clown instead of a dragon slayer. The theory of temporal parallel universes works a lot like that. This theory says that every decision you make creates a new universe. So you create two new universes when choosing to turn left or right at a crossroads. In one universe, you go right. Meanwhile, in the other universe, you go left. These new universes are temporal parallel universes. The idea is connected to the multiverse theory and time travel. If you look at the multiverse, it's simply a collection of all the different universes created when you made decisions in the past. So if you chose to drink coffee instead of tea this morning, you created a new universe where you drank tea. The universe where you drank coffee and the universe where you drank tea belongs to the same multiverse. Now, this is where the time traveling discussion comes into the picture. The theory states that even if traveling back in time was possible, you wouldn't be changing your own universe. Instead, because you traveled back in time to change one of your choices, you created a new universe where things happen differently. So, if you go back to your future, you'll realize that nothing actually changed, because the changes you made in the past only created a new universe that now has a different future. So, if you're watching Back to the Future, or any other movie with time travel in it, you can call those movies BS, because, according to this theory, that really isn't how time travel works. Mirror universes. Looking at a mirror, you'll notice that everything is flipped around. Your left becomes your right, words are also in reverse. The world you see in the mirror is essentially a reverse universe of the world you live in. It's like having a twin in a different world that exists within the mirror. This is similar to how the concept of a mirror universe works. This theory states that the multiple mirror universes exist alongside our own. It's like when you take an entire loaf of bread and make slices out of the same loaf. These slices of bread all belong to the same multiverse, universe, but are mirror universes of one another and are crusted in different ways. Most of these universes have the same events and rules, but with small differences. In a mirror universe, your evil twin might be like you in many ways, except maybe they're better at talking to girls or doing math. Maybe technology in this mirror universe is different from the technology we have in our universe. These universes are basically the same as ours, but are made unique by small changes. Maybe there's even a mirror universe where people actually like putting pineapples on pizzas.